Topic 3-2. This can be referenced with our textbook in Chapter 1, Section 4, pages 28 through 33. Special angle pairs. First, a definition: perpendicular lines. Lines that intersect to form 4 right angles, and all of them would have a measure of 90 degrees. Notice how on a page you don't always see it straight up and down. It can be noted with 2 crossed lines, but if it is shown to have a right angle box, then you know the measure of that is 90 degrees. All right, let's look at example 1. If line NP and line QR are perpendicular lines intersecting at O, find the value of X. Alright, so on this one, if 5x minus 9 has been told to us that they are perpendicular, then 5x minus 5 has a value of 90 degrees. Once you add 5 on both sides, you're going to have 5x is equal to 95. You divide this by 5 on both sides, and your x would be equal to 19. All right, let's go over some definitions. Not all intersecting lines form right angles, but they do form 4 angles that have a special relationship. So in this example, they're wanting us to look at the adjacent angles, vertical angles, and ones that form linear pairs. First, let's go the description of what an adjacent angle is. Adjacent angles are angles that have a common vertex and a side, but not a common interior point. So notice that this would have to be 2 lines that would be next to one another. Some examples could look like this. If I have an angle that doesn't form a linear pair, but I could have one that actually is formed by a ray separating a linear pair, then this is adjacent to this one. This angle is adjacent to that angle. So naming all the adjacent pairs in this example, quite a few of them, you can start with VZX is adjacent to XZW. Then you can just keep going around the circle. So let's name all of the ones that are adjacent, and then you can kind of look at them. Angle VZX and angle XZW, angle XZW, and angle WZY, angle WZY, and angle YZB. So what we do is just go around the circle, but they were the relationship is that they were next to. Being next to another one is an adjacent angle. Okay, looking at vertical angles, often tested over. Know that 2 non-adjacent angles formed by 2 intersecting lines. If you just cross 2 lines, the ones opposite would be vertical. So if I just draw 2 lines, denoted with arrows here, then this angle and this angle would be vertical. Although this angle and this one would also be considered a vertical angle. So the examples in this one would be VZY and XZW. Go ahead and name that one. VZY and angle XZW, but also angle VZX and angle VZY. Did I do that right? No. VZX and WZY. Sorry, make this say W. VZX and WZY. So if you want to note them on here, we can actually draw them. This and this is congruent, and this one are congruent. Vertical angles. Okay, the last one, a linear pair, adjacent angles whose non-common sides are opposite rays. A linear pair is always going to form a straight line with a pair of angles denoted with a ray, that this plus this one would equal the whole thing. And always make sure we remember this, that that's also 180 degrees. That whole measure on a straight line is always 180 degrees if it forms a linear pair. So there's quite a few linear pairs here. We can show them. I'll cover up the others. There's a line. So this one would be two linear pairs that formed a line. Could go around the circle. Those two are linear pairs. Those two are linear pairs. And those would be linear pairs. So there are 4 sets of linear pairs. So let's go ahead and name them all. Angle V, ZX, and angle XZW, angle XZW, and angle WZY, angle WZY, angle YZV, last one, angle YZB, and angle VZW. Okay, moving on. Vertical angles are always congruent. The sum of the measures of the angles are linear 180. So they're showing the measure of line AC and DE intersect at B. Find the value of X and measure of EBC. So let's look at this closely. You are looking, or you have two intersecting lines that we can first look at, that those two are considered vertical angles. So if you know this one and this one are equal to each other, we can solve for X to start with. So we have 2x plus the 20 is set equal to the 3x plus the 15. Algebraically, solving this out is going to be x is equal to 5. I've skipped the actual, we've done quite a few so far, so let's just move on. They're also wanting to find the measure of EBC. EBC is this line. Well, if you know that this is supposed to form a linear pair, and you've already discovered that your x is 5, you're able to plug it back in so that the measure of ABE is equal to, let's just plug it in. You're going to put this in for x plus the 20 is equal to 30. And we know that the whole thing, the measure of ABC, is supposed to be the 180 degrees minus what the measure of ABE is. And if we work out the algebra, this one's going to be equal to 30. So the measure, oh, I forgot to put that, measure. The measure of angle EBC would be equal to 180 degrees minus 30 degrees, which gives us 150 degrees. So if the measure of EBC, this is 150 because this is 30, making 180 for the straight line. Let's do another example. GH and JK intersect at I. Find the value of X and the measure of JIH. Let's mark that. JIH. It's always good to mark which one they're asking for. So start with J, I, and H. So they're wanting this one. That's the one in question. But you can't get this until you've gotten the answer for what this measure is. So just as in example 2, you've got to set these two equal to each other. And when you set those two equal because they're a vertical angle and solve for it, we'll go ahead and, I may not work through the whole algebraic example, but let's just set it up. you're going to have that equal to 3x plus 7. When you combine like terms, this is going to end up with a 3x is equal to 27, bringing the 13 over here and the 20 over there. Divide by 3 and you would have 9. So if x is 9, you're plugging in a 9 right here. 16 times 9 minus 20 is going to give you 124. So once we plug this in, we've discovered that this whole measurement is equal to 124 degrees. And then all you would do there is take 180, subtract from the 124. You've got those 2 degrees, so that your measure of angle JIH is going to be 156. And that's your answer, 156. So it was a two-step problem. You first knew vertical angles, then you knew, and I'll cover this up to show, the linear pair. So once you have the measure of this angle here, you're just subtracting from 180 to get the unknown. Okay, next page. Example 4. Again, we have one that intersects at M. Find the value of x and the measure of LMO and OMN. Well, this one we know that it's a linear pair, so you're looking at adding both of these together and setting them equal to 180. So when we combine 7x and 5x, that's 12x. You combine 20 and 10, that's 30, equal to 180. Solve for this, you've got 12x is equal to 150. Divide by 12, x is equal to 12.5. So plugging in 12.5 and multiplying by 7 and adding 20, this one's going to give you 107.5 degrees for LMO, and OMN, plugging in the same thing, 12.5 will give you 72.5 degrees. So we were able to find the linear pair. The main thing you got to remember to have done is to put it equal to 180 degrees. So these are your answers for the measures of those two angles. Last one. First we got to look at the sum of the measures. If the sum is always going to equal 180, then the two angles whose measures have that sum is called supplementary. Similarly, when the sum of the measures of two angles is 90, the angles are called complementary angles. So in this last example, if you've got the measure, they ask you a measure of 1 and 2 are complements of each other, and here are the two algebraic expressions for each angle, and you're just to solve for x, you know that these are actually equal to 90 degrees. So you would have 5x plus 35 is equal to 90 degrees. Subtract 35 on both sides, you would have 5x is equal to, what is that? 45? No. 35, 35, 65. X would equal 11. So that all they asked for here was to solve for the x. And that is the end of example 3-2.